What's so special about electrical safety? Millions of people use electricity every day, and it's not a major problem. Why all the fanfare about electricity in the workplace? Well, that's a good question. So let's begin with some basic understanding about electricity. Then we'll demonstrate the reasons all employees must use extra caution when using electrical equipment and appliances. There are different types of electricity or electrical energy: low voltage, high voltage, static electricity, alternating current, direct current, and so on. Static electricity is quite common because from time to time we experience a shock from a walk across a carpet, then touch a light switch or doorknob. Static electricity originates when two different materials are brought together, such as the soles of the shoes and the carpet. Then they're separated. When the two materials are forced apart, two different kinds of electricity are produced, one type on the carpet, the other on the shoe soles. They attract each other, trying to pull the shoe back to the carpet, attempting to recombine. If the two types are not permitted to recombine where first generated, and the person touches a doorknob or light switch, the electricity flows through the body, arm, and finger to leave by the doorknob or light switch. You can feel the shock as it leaves your body. The electricity is now gone, and you won't get another shock until you generate more electricity. That's static electricity. It can be generated in many ways, but for now, let's think of static electricity as electrical charges. How about those high voltage lines you see on telephone poles? Ever wonder how birds can sit on those lines without getting shocked? But if a human did that, they'd be in serious difficulty. That's part of understanding what electricity is and how it works. Basically, a circuit consists of three essential elements. One element is the source of energy, shown here. This supplies the driving force, or voltage, to make the current flow. Next, we must have a user of electricity, such as a light bulb. Thirdly, you must have transmission lines or wires to conduct the electricity. For current to flow, there must be a complete or closed circuit. If the wire is cut or disconnected somewhere, forming an open circuit, charges will accumulate and stop the flow of current. The bird must be part of the electrical circuit, and there must be a continuous flow of many charges, not just a few to charge up the bird. A human touching this same wire would probably be electrocuted because he would be grounded by the apparatus that lifted him to this position, such as a crane. The electricity would flow from the wire through the body to ground by way of the crane. Electrical equipment has a lot of wiring to carry electrical current, and naturally, wiring can become loose or even broken during daily use. When this occurs, a potential shock hazard can be created. Let's look at a plug on some equipment. The large prong, as shown here, is a grounding prong. Essentially, it's your protection from shock in the event of a malfunction or short in the equipment. If you were to follow this third prong wire back through the electrical outlet, it would lead to a ground. Remember the guy on the crane? Electricity went from the wire through his body to ground. In the case of this grounded appliance, electrical current will flow through this grounding prong, through the wire, and go to ground, not through your body. Electricity flows through the path of least resistance. Your body has quite a bit of resistance, and the grounding wire has very little resistance. If there is a choice, electricity will always flow through the ground wire and not your body. If there is no ground wire or other protection, electricity has no other option than to flow through your body. Electricity can also cause fires and explosions. Flammable agents and many other flammables found in work environments can be ignited by electrical sparks and even static electricity. Alcohol, acetone, various preparations and sprays that use these and other flammable components. Clothing, bedding, oils, greases, all are suitable fuel for an unexpected fire. Now that you know why electrical safety is so important, What can you do to help prevent electrical shock and other potential electrical hazards? Remember the third prong on the plug. The other two electrical blades on the plug are for electrical current to flow. We call this a ground plug. 2 current-carrying wires and 1 grounding wire. Almost all equipment must be protected by this system. The third prong is your protection, as long as the prong and wiring are intact. It should be inspected periodically to make sure the ground wire inside the system is properly connected, and each person using the equipment should always inspect to make sure the prong is intact and that all wiring is in good condition. Wiring or cables that are cracked, frayed, cut, or damaged must be replaced. Inspect the connections to your equipment. If you notice any loose or worn parts, report it so it can be corrected. Quite often, you'll find a cheater plug on electrical equipment. It has a receptacle for inserting your 3-pronged plug, but then it has a 2-pronged plug on the other end, with a wire extending down a couple of inches. These must never be used because they offer no protection at all. Supposedly, the short wire is connected to an outlet where it will serve as ground. If you notice this type of plug or adapter, remove it and get rid of it. It's dangerous. There may be some approved appliances and tools in your work environment that use only the 2-prong plug, as shown here. It can only be used with double insulated equipment. The protection is provided by double insulation inside the equipment and not through a grounding wire and grounding prong. The equipment must state double insulated on the manufacturer's data plate. If it doesn't state double insulated, then the 3rd prong and grounding wire plugs must be used. Follow your organization's policies and procedures regarding this type of equipment, as each situation is different. It's up to your organization to make the determination of what type of electrical equipment to use. Naturally, liquids and electricity don't mix. Never use electrical equipment when any part of your body is standing on or near fluids. Make absolutely sure the electrical equipment you use is safe to use and it's being used in a safe manner. Electrical safety is common sense and being aware of potential hazards. Generally, the best advice is never place electrical cords where they can be tripped over or receive excessive wear. Damage can occur inside the cords with rough treatment. Keep cords away from heat and water or other liquids. Remove electrical plugs from the wall receptacles by pulling on the plug, not the cord. Avoid kinking, crushing, or binding cords. Inspect cords and cables frequently for wear, especially at the plug and connectors. Use only safe-approved extension cords. Avoid overloading any electrical circuits. This includes not using octopus adapters, which allow you to plug in more appliances than is authorized on each receptacle. Extension cords must be of the same thickness and rating as that of the equipment cord. Any questions regarding the serviceability or safety of the equipment should be referred to management. Don't use any defective electrical equipment if it becomes excessively warm or hot. Have it checked out. Immediately unplug any equipment if it begins to smoke or does not seem to work properly. If electrical equipment gives you a shock, no matter if it's just a slight tingle or mild shock, unplug it and don't use it until it's been repaired or replaced. Have we left any important information out of this program? Probably 1,000 other things, but the program has been designed to make you more aware of electrical safety so you can continue your education and knowledge by knowing and understanding your organization's policies and procedures. Being more aware about safety and the safety of all employees. It's a worthwhile endeavor, and it does save lives. Thank you.